Hi Year 12. So start off retrieval roulette, get answering these in your workbook for me. Thank you. Okay, so here's the answers. I will draw that answer to question 9 in just a wee second here. Okay, so get the rest of them marked there for me. So question 9 was the two-way switch. So let's say we had our situation with a bulb that we wanted to be able to turn on or off in two different places. We would have this kind of situation going on here. So you're going to have like connection points here, and then your switches, you'll have one switch here and then one switch here. So the way I've drawn that there, the bulb will be lit, and then no matter which switch you would press, the bulb's going to do the opposite of what it's currently doing, and then that's always going to be the case. So if I was to flick this switch, then I don't have a complete circuit anymore. Then if I go up my stairs and do the other one, I do have a complete circuit. So it's always going to do the opposite of what it's currently doing. Okay, right, starting on to magnetism then. Unfortunately, I was too stupid to remember to bring some magnets home with me, so I can't even demonstrate these things, so apologies, I am sorry. So I'm on page 202 in our notes, by the way, so if you're not already there, can you please open up there and then fill in these notes for me? So we all know a little bit about magnetism already. The stuff we're doing here is basic. It's whenever we start to go into electromagnetism that it starts to get fun. And by fun, I mean a little bit more difficult. So a magnet is a device that can attract objects which are made from the following materials. So steel or iron, nickel or cobalt, right? These substances are known as ferromagnetic materials. All other substances are non-magnetic. This little bit here is just saying that the poles of the magnet, so the two ends of the magnet, is where the strength is the strongest. And what I'm really avoiding saying here, because I haven't mentioned it yet, is that the magnetic field is the strongest there. Okay, so if we were in school, we would get to be playing with iron filings, dropping them on the page and all that, but sure, you remember doing that in first year, don't you? Most of them would cling to the ends of the magnet and very few to the middle. So the ends are called the poles, and there's a north pole and a south pole. If you have a wee magnet and you like just suspend it from a bit of string, it'll always rotate and then it'll settle in a north-south direction. And because of that, that means it's really good for navigation. So before we all used our phones for GPS and all that kind of stuff, people would have used compasses way more than they do these days. And if you were doing your Duke of Head, you maybe got a wee go with that. Just down the bottom here, the two most common like shapes of magnets that we'll be dealing with are bar magnets and horseshoe magnets. Bar magnets the most. So if you just label those two, so that if I'm using those words, you know what on earth I'm on about. Okay, so on to 203 then. So again, this is stuff you already know. If we get two bar magnets, so remember they're the ones that they're literally like, oh, we bar, so with a pole at either end. If you bring two like poles together, so that means two poles that are the same as each other, so for example two north poles, then they're going to repel away from each other. So they repel, and repel just means push apart. Same thing for what happens when two south poles are brought close together. They repel. If we bring a north and a south pole close together, then they're going to like jump together or stick together. So they attract. Look, there's not even enough room for you to write that in. They attract. Okay, now we're going to sketch in this wee shape here, or sorry, in this wee space here, the shape of the magnetic field. But before we do, can I just explain what the magnetic field is? So say this is my magnet, right? I said there earlier that at the two ends, the two poles, that's where the magnet is strongest. So that's where like the magnetic force would be the biggest. The magnetic field is just the area around the magnet where the magnetic force can be felt, or where the effect of the magnet can be felt. So if I have one of those, you know the wee red and blue ones we use in school, if I have one of those wee bar magnets, they're not that strong. If I held a bit of one of those magnetic materials, so iron or steel or nickel or cobalt, if I held it like way up here, it's going to be outside of its magnetic field, so this isn't going to affect it. Whereas if I bring it closer, say I bring it to here, then that probably is going to be within the area where the magnetism can be felt from that, if that makes sense. So the magnetic field is just the area around a magnet where the magnetic force can be felt. And with a bar magnet, you need to know the shapes of them. There's a few rules that we have to follow whenever we're drawing it. So watch me and listen to me draw this and then sketch it in. Okay. So if I have my bar magnet here, so see in your notes it says that we would have been putting the magnet underneath a piece of paper, sprinkling iron filings over the paper and sketch what we see. What I'm drawing here isn't realistic for what we would see. What I'm actually drawing is just the magnetic field, and if we were in class it would be the same. I would maybe get you to sketch both, but this is like the neat version of what you would see. Anyway, back to this. So let's say this is my North Pole and this is my South Pole. We always draw on magnetic field lines and we draw them on really carefully so that none of them touch each other, right? That's a wee thing that they would take marks off you for. So see the way I've managed to draw those and they're not overlapping or they're not touching each other? Be careful with that. The next little rule is that you would always be wanting to draw like at least 3. So see the way I'm drawing 3 field lines on each side. Aim for that. Now I'm going to contradict myself because later in the electromagnetic stuff I'm probably only going to draw 2, but that's because it gets a wee bit too messy. Now the way I draw, what happens at the ends here is like this, and it looks a little bit random, right? But I'll explain what I'm at. Really what these are is like the start and the end of another one, okay? And then this here I suppose is just the extreme. So we've had 2 rules so far. One is that your magnetic field lines, which are what these are called, sometimes can be called lines of flux. They never touch each other. Second rule is that you draw at least 3. I would never bother drawing more than that, but if you draw 3. The next one is that we always mark on the direction of the magnetic field lines. Now obviously we would not see that if we were just pouring our iron filings onto a bit of paper, but anytime you draw a magnetic field you mark on the direction, and the magnetic field always points from north to south. Now please be super careful whenever you're marking on arrows, because see the way there I just started with one and then just copied the rest of it. It's not always going to be like that. Like depending on the situation you're in, your arrows are going to be pointing in both directions. So from north to south. So never be thinking like left to right or up to down or anything like that, because it's going to change. Because look, out of north and into south means these ones are pointing the other way. So just be careful. It's so easy to make a silly mistake. So out of north and into south. Okay, so pause, get that drawn in as neat as you possibly can. Okay, so down at the bottom here, that's just what I was saying. This area around the magnet is called the magnetic field. In order to see magnetic field lines and mark on their direction, a plotting compass is needed. The needle in the compass is a tiny magnet which is free to spin. Again, raging, I did not think to bring these home with me because I actually really like showing that. I don't think anyone ever really cares as much as I do. I tell you what, I'll try and find a wee video on YouTube for you to see that, because it is cool, right? I'll explain to you here what it actually shows. So we have these wee, now you don't have to draw these down. Well, do you know what? I am going to make you. So sketch out another wee, whatchamacallit, another wee magnet here, right? So if I have my magnet north to south, we'll do again. And just like the compass that you would use in your Duke of Ed, it's just like a wee tiny compass. So if I was to set a bunch of those like out around it, the wee needle on them would point north to south. So like it would be going like that. maybe drawing this too small to see, but like away from north into south. What I normally do is I'll set a magnet down and just like move it round, and you can see the wee arrow moving. It is cool, I promise. Well, I don't know that it is, but I think it is. So let's just label this as our plotting compasses in case you look back on that and think, what on earth even is that? Okay, so draw that in as well for me, please. Right, over the page is just a wee way that you can use your plotting compass to draw that magnetic field that we were just drawing there. So basically you would have your magnet, you'd have your wee plotting compass, and you would set it at different positions. You would let it settle, and then see the way they're marked on here, like the wee dot at the two extremes, or the way the wee compass is pointing. Then if you keep on doing that, you will end up tracing out the shape of the magnetic field. So that's just how they can be used to draw. Right, on to 205 then. So important points about the magnetic field. So they go from north to south. So write this the way I have it written, not necessarily the way I'm saying it. And the field direction is defined as the direction in which the force on a north pole would act. So the north end of the compass points in that direction. So do you know the way it was going from north to south? That's why it's pointing that way, because it's the way a north pole would act, and north is attracted to south. Third wee point, the magnetic field is strongest where the field lines are closest together. So if I go back to that wee diagram, at the poles you'll see that that's where the field lines are the closest together. And then I tried to draw it here so that like here they were getting a bit further apart. There's no field lines in the middle of the magnet. There's no magnetic field there. Now, underneath here, once you get that down, sorry, I'll let you pause that and get that down. Underneath here, we've got the situation whenever we have our two poles which are being brought together, right? So if I cover one, first of all, so that you're not looking at too much at once. So if we have a north and a south pole together, remember that's whenever the magnets are going to attract each other. So what we end up, if we were to sprinkle our iron filings on there, we would get wee lines going straight across, and it still follows the rule from north to south. Now, you still have your normal magnetic field lines for, like, if the rest of this magnet was drawn in here, you would still have the full shape, the original shape that we drew there. You still have the original one here. The only difference is like the interaction at the two poles. So draw that one down for me. And then let's also look at what happens whenever we bring two like poles together. So whenever you bring two like poles together, they repel, they push apart. So we end up with the magnetic, again, we've got a full magnetic field for this one, a full magnetic field for this one. It's just what happens in between that's different. So whenever you bring two like poles together, you end up with this wee area in the middle. You can see I've marked it NP for neutral point. That's just a point where the magnetic fields will cancel each other out. So you would get no iron filings there. You would get this little blank space on your page whenever you were sprinkling them on. Just be careful if you're ever asked to draw that you do the arrows in the right way. So in this one, because it's two norths I've drawn, the arrows are going out. If it was two souths, they would be going in. So get those both drawn in for me. Also make a wee note of what neutral point is NP. Right, year 12, I'm afraid that's it for today. It feels very, very short. So do make sure you take your time and like test yourself on drawing those magnetic fields, going from north to south and all the rest of it, because the retrieval roulette and noting down those notes is not going to take an hour. And then next day we'll start and we'll move on to electromagnetism. Right, we're nearly finished. Can you believe it? Oh, right, bye.